with the name of Allah. This is a new lecture in Cost Accounting 2. It's entitled Cost Volume Profit Analysis Under Risk. What are the differences among certainty, risk, and uncertainty? Under certainty, the company has many alternatives. Any alternative has one action. For example, if the production units equal 10,000, so the units sold will be 10,000. If the production units equal 15,000, so the units sold will be 15,000. Under risk, the company has many alternatives. Every alternative has course of actions or many actions. Every action has a probability. For example, if the production units equal 10,000, the units sold may be 9,000 by probability 90%, or the units sold may be 10,000 by probability 10%. The second alternative, the production units equal 15,000. The units sold may be 13,000 by 60% probability or 11,000 by 40%. The total probabilities for the one alternative must be 100%. You can notice that 90% plus 10% for the first alternative equals 100%, and 60% plus 40% for the second alternative equals 100%. Under uncertainty, the company has many alternatives, but the company has no idea about the actions or the probabilities. For example, if the production units equal 10,000, what will be the units sold? The company doesn't know. If the production units equal 15,000 units, what will be the units sold? The company doesn't know. The cost volume profit analysis is an important technique which is widely used for short-term planning purposes. It is dependent on an equation, that is, break-even point in units equal fixed costs divided by contribution margin per unit. The contribution margin per unit equal selling price per unit minus variable cost per unit. In cost volume profit analysis under risk, you will study how to determine the probability of sales volume and profit. To determine the probability of sales volume, you will use normal distribution curve. This curve, as you see in page 39, it's like the shape of the inverted pie. From the normal distribution graph, you can determine the probability of sales volume. If you have the sales volume, for example 1000, from this shape you can determine what is the probability. But this method is not accurate method, so we invert the normal distribution into standard normal distribution. The standard normal distribution has the same characteristics of normal distribution, but units in normal distribution is sales volume, but units in the standard normal distribution is sigma. After the mean, there is 1 sigma, 2 sigma, 3 sigma. Before the mean, there is negative 1 sigma, negative 2 sigma, negative 3 sigma. The area between positive 1 sigma and negative 1 sigma, this area has a probability equal 68%, and the area between positive 2 sigma and negative 2 sigma, this area has a probability equal 95%, and the area between positive 3 sigma and negative 3 sigma has the probability is 99%. To determine the probability of sales volume, there are 4 steps. Number 1. Determine mean of sales volume. Number 2. Determine standard deviation, sigma, of sales volume. Number 3. Calculate Z value. Number 4. Determine the probability using a statistical table Z. Example 1 in page 40. The following are data for a manufacturing company. Sales volume during the last 4 years are first year 4,000, second year 5,000, third year 5,000, fourth year 6,000, selling price 300 per unit, variable cost 175 per unit, the budgeted fixed cost 580,000. It's assumed that the probability distribution for the estimated sales volume is normal with a standard deviation sigma of 400 units. The selling price, variable cost, and the total fixed cost are assumed to be certain. Note that this table has Z value and the probability. When Z value is 0.2, the probability is 0.4207, and so on. Required. Number 1. What is the probability of sales volume being greater than break-even point in units? Number 2. What is the probability of sales volume being greater than 5,200 units? Number 3. What is the probability of sales volume being less than 5,200 units? And number 4. What is the probability of sales volume being between 4,600 and 5,600 units? The first step is to calculate the mean. The mean equals sales volume for the last 4 years divided by 4 years. That's mean 4,000 plus 5,000 plus 5,000 plus 6,000 all divided by 4 equal 5,000 units. So the mean equal 5,000 units. The standard deviation sigma is given 400 units. The third step is to calculate Z value. Z value equal x minus x bar or mean divided by sigma or standard deviation. Required number 1. What is the probability of sales volume being greater than break-even point in units? Here x equals break-even point. The break-even point equal fixed cost divided by selling price per unit minus variable cost per unit. So 580,000 divided by 300 minus 175 equal 4,640 units. Z equal x minus x bar divided by sigma. So 4,640 minus 5,000 divided by 400 equal minus 0.9. From the table at Z equal 0.9, the probability is 0.8159. Z value may be negative or may be positive. Here Z negative, so it will be in the left side, and the probability will be the area on the right side. The question here about the probability if the sales volume is being greater than the break-even point. Greater than, that means the area on the right side. So the probability will be the same area is 0.8159 equal 81.59%. Required number 2. What is the probability of sales volume being greater than 5,200 units? Here x equal 5,200 units, mean equal 5,000, and sigma equal 400. So z equal 5,200 minus 5,000 divided by 400 equal minus 0.5 sigma. From the table, at z equal 0.5, the probability is 0.6915. Z here is positive. That means it will be in the right side, and the probability will be the area in the left side. The question here about the probability of sales volume is being greater than 5,200 units. This area will be 1 minus the area on the left side, 0.6915 equal 0.3085 equal 30.85%. Required number 3. What is the probability of sales volume being less than 5,200 units? Z equal 0.5 and the probability is 0.6915. The required about the probability of sales volume is being less than 5,200 units. That means it will be equal 0.6915 equal 69.15%. Required number 4. What is the probability of sales volume being between 4,600 and 5,600 units? We'll calculate Z at 4,600 units and at 5,600 units. Z at 4,600 equal 4,600 minus 5,000 divided by 400 equal minus 1. Z at 5,600 equal 5,600 minus 5,000 divided by 400 equal 1.5. From the table, at Z equal 1, the probability is 0.8413. At Z equal 1.5, the probability is 0.9333. So the probability equal 0.9333 minus 0.5 plus 0.8413 minus 0.5 equal 0.7746 equal 77.46%. Example 2. Alex Institution, a manufacturing company, assumed that the probability distribution for the estimated sales volume is normal with a mean of 8,000 units and a standard deviation sigma of 2,000 units. The selling price, variable cost, and the total fixed cost are assumed to be certain. Selling price of a product for the next accounting period is 18 per unit. Variable cost is estimated to be 12 per unit. The budgeted fixed costs for the period are 24,000. Note that there is a table. This table shows Z value and the probabilities. Required number 4. What is the estimated sales volume if the probability of sales volume being 95.4%? In this required, the probability is given 95.4%, and the question is about the sales volume. That means we need to calculate x. Here the probability is given 95.4%, the mean is given 8,000 units, and the standard deviation sigma is given 2,000 units. X equal mean plus or minus 2 sigma, because at this probability x equal mean plus or minus 2 sigma. So x may be 8,000 plus 2 times 2,000 equal 12,000. And 8,000 minus 2 times 2,000 equal 4,000. So X here will be between 4,000 and 12,000 units. By the end of this lecture, you have skills to determine the probability of sales volume, but you need to solve more exercise to catch more skills in this area. Thank you.